will start from numerical problems under resistors connected in series and parallel. We will be solving problems from page number 110. We have problems. You need to understand step by step so that if they ask indirect problems also, you should be able to answer them. So just look at our first question. Judge the equivalent resistance when the following are connected in parallel. Here they are given parallel, so no need to worry about series. And we have two questions. A, the resistors are 1 ohm and 10 to the power 6 ohm, and in the B, 1 ohm, 10 to the power 3 and 10 to the power 6 ohm. So let us solve the first question. A, what is the formula for resistors connected in parallel? That is 1 Rp is equal to 1 by R1 plus 1 by R2 goes on. We have only two resistors, so we will have only R1 and R2. This is our formula to calculate equivalent resistance connected in parallel. So we have R1 as 1 and R2 as 10 to the power 6, right? Substitute in the formula. R1 is 1 and R2 is 10 to the power 6. Now LCM, take LCM for 1 and 10 to the power 6, we will get 10 to the power 6. And what about the numerator? We need to multiply a number with this number and our answer should be 10 to the power 6. So if we multiply 10 to the power 6 into 1, we will get 10 to the power 6, right? So our answer will be 10 to the power 6. So what happens here? 10 to the power 6 into 1, what we will get? 10 to the power 6. So answer will be 1. So this is our numerator here. So next step is what? What is the value of 10 to the power 6? That is, we will get 0 6's. What happens when we add this one to 10 to the power 6? We will get this number, and this one is 6 zeros. And we are having this in the form of 1 by R. We always conclude with reciprocal of this resistance, that is R. Then what happens? It will reverse. Reciprocal of earlier step. So 10 to the power 6, it will come here. And what is this number? We will get this in denominator. Calculate this. We will get 0.999 ohm as answer. Therefore, equivalent resistance is approximately equal to what? 1 ohm. Here we have here itself this one, equivalent resistance. This is approximately equal to 1 ohm. This is the answer. Now in the same method, we need to solve for these three resistors. What we need to change? All we need to change is, no, we need to add one more term, that is 1 by R3. What is the value? First one we have 1 ohm, second one we have 10 to the power 3, and third one we have 1 by 10 to the power 6. Now what will be our LCM? Take 1 will be 1, 3 and 6. Find out the LCM, we will get 10 to the power 6. Now what about numerators? Which number we need to multiply with 1 to get 10 to the power 6? Into 10 to the power 6, right? If we multiply 1 into 10 to the power 6, we will get 10 to the power 6. Hence, these are just a shortcut I am telling. If you know your method, just follow that one. And next is 10 to the power 3. Here we need to remember, write down somewhere as a note. For this we need to follow this formula, that is a to the power m into a to the power n gives a to the power m plus n. See, observe here, we should not multiply the powers. We need to add. So what we have here? 10 to the power 3. So we need to multiply with 10 to the power 3 to get 10 to the power 6, right? It will not become 3 to 3, 9, because we need to add here m plus n. So 10 to the power 3 will be our answer. Here we need to write 10 to the power 3. So next one we have 10 to the power 6 into 1, we will get 10 to the power 6. Write down 1. Now convert, what we will get? We will have 6 zeros what happens when we add 1000? Where we'll get 1000? We'll get 1 here, then we need to add 1, we'll get 1 here, the rest of the thing 10 to the power 6, that is 6 zeros. So multiply, now we have, not multiply, divide this one, we have 1 by r, reciprocal of this will get 10 to the power 6 divided by 100, 100, 1, and again our answer will become some 1 point, we'll get again 0.99 only. I think calculate and see how much we'll get. This is also approximately equal to 1 ohm, right? Hence equivalent resistance is equivalent resistance is approximately equal to 1 ohm. See, the first problem is very easy. We have resistors, all we need to convert them into this formula and find out the answer. So you should be very careful while converting this to this term, right? You need to write properly the denominators and numerators with LCM method. Let us solve our next problem. This is our second problem. So always we need to read a problem properly, so that we need to identify what are the given things and what are the things which we need to find out. See, here we have an electric lamp of 100 ohm, a toaster of resistance 50 ohm, a water filter of resistance 500 ohm are connected in parallel. So here they are given, they are connected in parallel. So again, don't worry about series, to a 220 volt source. What is the resistance of an electric iron connected to the same source? We need to find out one resistance of an electric iron connected to the same source that takes as much as current as all three appliances. And what is the current through it? We need to find out current also. So what are the given things? Electric lamp of 100 ohm. So this will be our R1, that is 100 ohm. What about R2? That is 50 ohm. R2 is 50 ohm. What about R3? That is 500 ohm. 500 ohm. And we have 220 volt of the source. V is equal to 220 volt. What are the things we need to find out here? Using all these three resistors, we need to find out one resistance, then current, that is I, current flowing through it. Then one more thing we need to find out, what is that? The resistance of an electric iron. Again we need to write the term R, so I will use R bar to differentiate between this resistance and this resistance of an iron connected. So these are the given things and these are the things which we need to find out. Now let us draw a circuit diagram. We have resistors and one battery connected in parallel, right? So it is easy. Write the diagram. Write it properly. Next, what we have? A battery or a cell. See, observe, this is a short line, this indicates negative terminal, and this is a bigger line which indicates positive terminal. So this is 220 volt, and this one is our R1, R2, R3, that is 100 ohm, 50 ohm and 500 ohm. Current always flow from positive terminal of the battery, right? So direction it goes like this. So this is our schematic representation of electric circuit related to this problem, and these are the given things. I will rub this one, you write down the problem or else copy down from the textbook. Use the parallel resistors connected in parallel formula. that is 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Same procedure which we solved earlier problem. Now solve yourself. 100 plus 1 by 50 plus 1 by 500. Take the LCM, we will get 500. Then 100 into 5, we will get 500. 50 into 10, we will get 500. 500 into 1, we will get 500. So what is the answer? 10 plus 5, 15. 15 plus 1, 16 by 500. 16 by 500. This is our 1 by R. Now reciprocal of this, we will get 500 by 16. So this is our first R. I'll write here. Since I'll rubber, go to the next step. 500 by 16. Either you can leave as it is or else divide and keep a single answer. Now our next step is to find current, that is I. Let current, what we at the end we saw that we need to find out current flowing through it, right? So current flowing through it will be I. Write down each and everything in words. Current flowing through it be I. So according to which formula we need to use here to find out I? Go back to Ohm's law. What is Ohm's law? V is equal to IR. According to Ohm's law, V is equal to IR. Now we need to find out I. Therefore, what happens? V by R. Right. We have almost all the terms. What is V? V is here. 220 volt. Substitute to this formula. R is this one. Well, here we have 500 divided by 16. What will be our next step? Sorry, this is what? 220. 220. This will go to numerator into 16 and we will get 500 here. Substitute everything and calculate. We will get 7.04 as our answer. That is I, right? Current is 7.04. What will be the unit? Ampere. Now I'll write this here. 7.04. We need to conclude the answers with the proper statements. So for this we can write it as, therefore 7.04 ampere of current is drawn by all the three appliances. We need to find out R dash. Therefore current drawn by an electric iron connected to the same source of potential, that is 220 volt, and let R dash be the resistance of electric iron. Resistance be resistance of electric iron. So again here we need to use Ohm's law, but R will become R dash and R dash. We need to find out R dash. Our formula will become V by I. V is what? 220 volt and I is 7.04 ampere. Calculate. We will get 31.25 ohm as answer. So this problem is very easy. Just we need to concentrate which and all we need to find out. Solve step by step. First we calculated using these three resistors or resistance that we got 500 by 16. Then using this R we calculated current, right? After calculating current we calculated resistance of an electric iron, that is R dash 31.25. Problems looks little complicated, but it's very easy. Our next question is third question, that is, what are the advantages of connecting electrical devices in parallel with a battery instead of connecting them in series? Geeta ma'am explained this one, so go back to her videos and find the answer and write it as homework in today's class. So now I'm directly going for fourth problem. So what is our fourth problem? How can three resistors of resistance 2 ohm, 3 ohm and 6 ohm be connected to give a total resistance of 4 ohm, to give a total resistance of 4 ohm and 1 ohm. Read out the question again and understand what they are asking us to find. We need to build a circuit in such a way using these three resistors, and we need to get our final resistance as answer 4 ohm and 1 ohm. So let us go for the first one, that 4 ohm. Now I'll write the circuit diagram. See, the following circuit diagram shows the connection of three resistors to get 4 ohm. Write it in your own words or else copy this one. This is our circuit diagram. We have a cell and we have two resistors are connected in parallel. Let it be 3 ohm and 6 ohm, and another one is 2 ohm. So write down every explanation in statement way. 3 ohm and 6 ohm, that is 3 and 6 resistors are connected in parallel. Here 3 ohm and 6 ohm are connected in parallel. Next, to find out the equivalent resistance of this 3 ohm and 6 ohm, we need to use the formula, that is 1R is equal to R1 plus R2. Use this 3 as R1 and R2 as 6 ohm. We'll get. Now find out quickly what is the LCM. Here we'll get 6, and what is our numerator? 3 into 2 and 6 into 1, that is 3 by 6. So this is in 1 by R form. Now reciprocal of this, we will get 6 by 3 and 2 ohm is our answer. We got answer as 2 ohm. Hence this combination, which combination? Combination of these two resistance is connected to 2 ohm in series. Therefore, total equivalent resistance. Total equivalent resistance will be 2 ohm. What is this answer? Plus 2 ohm. How much will we get? 4 ohm. What is our expected answer? 4 ohm. Now conclude the statement. Hence, the total resistance of a circuit is 4 ohm. It is easy, right? So to get this answer, according to that, we need to build a circuit and we need to find out the answer. Next one is B. We need to get answer as 1 ohm. So we need to alter the circuit diagram. Here again we will connect this resistance into parallel. So let it be 2 ohm, 3 ohm and the one is 6 ohm. This is volt. Here all 2 ohm, 3 ohm and 6 parallel, right? Now what about the formula? We need to add 1 by R3. R1 is 2 ohm, R2 is 3 ohm and 1 by 6. Now what is our LCM? We'll get 6 as LCM. 2 3s are 6, 3 2s are 6 plus 1. How much you get? 3 plus 2, 5, 5 plus 1, 6 by 6. Now what about the reciprocal? Same thing we'll get. So we'll get 1 ohm as answer. What is the expected answer? 1 ohm. Easily we got 1 ohm. Therefore, the total resistance is 1 ohm. The problem is very easy. Practice. You can get easily answer for A and B. Our next question is, what is the highest and the lowest total resistance that can be secured by combination of 4 coils of resistance 4 ohm, 8 ohm, 12 ohm and 24 ohm. Observe the question. The first one is the highest resistance and the second one is lowest total resistance. So we need to see by connecting these resistance where we will get highest value and lowest value. So we have two methods, which is that resistors connected in parallel and resistors are connected in series, right? First we will solve resistors connected in series. These are our resistance. So write down like given. What are given things? Given R1 is 4 ohm, R2 is 8 ohm, R3 is 12 ohm, R4 is 24 ohm. What is the formula of series? Rs is equal to R1 plus R2 plus R3 plus R4. Substitute 4 plus 8 plus 12 plus 24. Add them. 4 plus 8 12, 12 plus 12 24, 24 plus 24. We got 48 ohm as answer. We don't know till whether it is highest or lowest because we need to solve one more thing in parallel, right? Now what is the parallel formula? 1 by Rp is equal to R1 plus R2 plus R3 plus R4. R1 is 4 plus 8 plus 12 plus 24. Now take the LCM, we will get 24. 4 6 are 24, 8 3s are 12 2s are 24, 1s are. Add this, how much will get? 6 plus 3 plus 2 plus 1. 12, right now. 9, 10, 12, 24. This is what? This is our 1 by R. Now reciprocal of this will 24 by 12. So what will get? 2 ohm. Right. So here we got 48 and we got 2 ohm. So which one is highest here? 48 is highest. So this is our A. By connecting, now write on the conclusion, by connecting these resistors in series we will get highest total resistance. And here by connecting these 4 resistance in parallel we will get the lowest total resistance. So I'll write for one, you copy it for another one, okay? To get highest resistance, what we done? We have to connect them in series. So same thing for the B, the lowest value. Therefore, to get the lowest resistance, we have to connect them in parallel. Write down another problem B. Till now we understood how to solve these problems. See, we copy down all this problem in your notes which you are maintaining for physics 1. Along with this, I'll give few more problems as a homework. You need to submit me both all these 4 questions as well as my homework question. I want to see how you are writing, whether you are following each and every step. You need to conclude with a statement. Wherever the necessary items you need to add. Like in earlier problem, we are using according to Ohm's law. All those things you need to mention to get complete marks. Okay. Let us end today's class.